Okay, class, today is the first section of Unit 4, and we're going to talk about identifying linear functions here. The objective is to identify functions and linear equations. We're also going to graph linear functions that represent real-world situations and give their domain and their range. Domain is your x, range is your y value. Okay, so a function whose graph forms a straight line is called a linear function. Has line in it, linear function. Okay, the graph represents a function because each domain value x is paired with exactly one y value. Okay, so let's check that. Let's write our ordered pairs out here to the side. Remember, your ordered pairs, your x and your y. So we have 1, 120, 2, 240, 3, 360, 4, and 480. Okay, so 1 goes to 120, 2 to 240, 3 to 360, 4 to 480. So for each domain, you have exactly one range, y value, okay? So it's a straight line. It's already graphed for you, so it is a linear function. One other thing you can test to see if it is a linear function, it's called the vertical line test. Okay? The vertical line test is if you take your marker and draw vertical lines on that line, and if it only intersects that line in one point, then it is a linear function. Okay. Okay, so we need to see if this represents a function. So let's list some of our ordered pairs to double check. Okay, well guys, you know it's a linear function. Do the vertical line test. It's only intersecting it in one place, and it is a straight line. So, but let's look at the domain and range and make sure that you understand how to do it with the domain and range. All right, so let's pick, these 3 points right here. So we have 0, negative 5. We have 2, negative 3. And we have 5, 0. Okay, so for the x value, there's only one output y value, which is negative 5. So there's no 0, only matches up with negative 5, okay? So you can say that this is a function because each domain, which is your x value, has exactly, has exactly one range, which is your y value. So this is a linear function. Okay? So you can tell it is because it's a line. You can do your vertical line test. It only intersects one place on that line. And then you can look at your domain and your range values. If your domain has exactly one range value, then it's a linear function. Okay? All right, so let's do the vertical line test first. I draw a line here, line here, line here, line here. It is only intersecting in one point. So, is this a function? Well, according to your vertical line test, it does look like it's a function, right? Okay, so let's check with our x and y. Okay, so let's check this point. Let's check this point. And let's check -2, -1, this point. Okay, so we have 2, 1, we have 0, 0, and we have -2, -1. Okay, so for this domain, we have exactly one y value. For this domain, 1 range, this domain, 1. So, is this a function? Guys, this is a function, but is it a linear function? It's not linear. It does not form a line. Okay, so it is a function, passes the vertical line test. Each domain has exactly one range, but is it linear? No, it's not linear. It's curved, okay? All right, let's look at number 3 here. Vertical line test. This is a vertical line, so there's many points there. So is this a function? This is not a function. All right, let's look at our x and y value and do it that way. All right, so let's pick, this point, and this point. So we have -2, 2. We have -2, 0. And we have -2, -2. Okay, so for our domain, we have -2. And then for our range, we have 2, 0, and -2. So there is not exactly one output for this domain. There are 3 different ones. So it is not a linear function, and it is not a function. Okay. Same thing on this one. Let's do vertical line test. So if we did vertical line test, intersects in one point. Okay, so it's a function. Let's see if it's a linear function. Linear function, let's look at our x and y values. So let's pick this one, this one, and this one. So we have -2, 4. We have 0, 4, and we have 2, 4. Okay, so for our domain, which is our x, we have -2, 0, and 2. For our range, which is our y, we have 4. Okay, so -2 has exactly one output, one range, 4. 0 has exactly 1, 4. 2 has exactly 1. So yes, this is a linear function. Okay, you can sometimes identify a linear function by looking at a table or list of ordered pairs. In a linear function, a constant change in x corresponds to a constant change in y. So what that means is here are our x values and our y. We're looking for a pattern. We're looking for the arithmetic sequence. Okay, so how do I get from -2 to -1? I'm adding a +1. How do I get from 7 to 4? I'm actually adding -3. Okay, so if you notice, my sequences are the same, and therefore this satisfies, and it's a linear function. And you can see when we graph it, it's a straight line. Now let's look at this one. Our x values have a consistent arithmetic sequence, add 1. But look what happens with our y value. Our y value is not consistent. You go from add -3, add a -1, then add 1, and add 3. So therefore, it's not a linear function. You can tell when you graph it. This is something called a parabola, and we'll talk more about that later. Okay, we check on time. Okay, tell whether the set of ordered pairs satisfies a linear function and explain. Okay, so here is our x value and our y. Remember, you have your x and your y. So when x is 0, y is negative 3. When x is 4, y is 0. When x is 8, y is 3. When x is 12, y is 6. When x is 16, y is 9. Okay, how do we get from 0 to 4? 4 to 8. 8 to 12. 12 to 16. Check. They're all consistent. Okay, how do we get from negative 3 to 0? 0 to 3. 3 to 6. 6 to 9. Check. They're all the same. Therefore, this is a linear function. Okay, I'm going to be quiet. Let y'all do 6 on your own. Okay, this one right here did not check. It's not consistent. Therefore, this is not a linear function. When you graph that, you're going to see a parabola there, but we'll talk more about that later. Okay, another way to determine whether a function is linear is to look at its equation. So guys, there's 3 types of linear equations, and we're going to talk about the first one today. A linear equation is an equation that can be written in the standard form. Okay, so here is your standard form. You have ax plus by equals c. A, b, and c are real numbers, and a and b are not both 0, because if these are both 0, you would have 0 equals c. Okay? All right. Notice that when a linear equation is written in standard form, x and y both have exponents as what, class? What exponent is with this x and y? If there's not one there, it is 1. Okay, this is for a linear equation. X and y do not multiply together. That means you don't have x, y. Okay? And x and y are not denominators. You cannot have something like this in that standard form. They're not denominators. Exponents or radical sign. Okay, so exponents would be like 2 to the x or 3 to the y, and radical sign is your square root sign. You can't have x and y inside that square root sign. Okay? All right, so let's look at some of these. And guys, I'm going to stop and do a part 2.